Good morning, everyone. I am Chalma Reddy. Welcome to CR Maths class. Today I am going to start binomial theorem, competitive. Okay. What is the binomial expansion? An expansion consisting of two terms is called binomial expansion. An algebraic expression consisting of two terms with a positive or negative sign between them is called binomial expression. So I will say that an expansion consisting of two terms is called binomial. An expansion consisting of three terms is called trinomial. Okay. So in that binomial expansion, observe here, x plus a whole power 1. X plus a whole power 1 means what we can write, students? That is x plus a only. And x plus a whole square means x square plus 2xa plus a square. X plus a whole cube means x cube plus 3x square into a plus 3x a square into plus a cube. Here observe that the first term, there are two terms in binomial expansion. The first term x is going to decreasing, x cube, x square, x power 1, finally x power 0. Okay, the first term is going to decrease. Then what about second term? See here, x cube only is there. X cube into a power 0. Here a power 1. Here a square. Here a cube. The second term is going to increase. But the sum of the powers of first and second term should be same. Here see the first term. X cube into a power 0. The sum of power is 3 plus 0, 3. Second term 2 plus 1, 3. 1 plus 2, 3. And last term power also 3 only. And this is also observed. Okay. And one more thing, the right hand side expansion is called binomial expansion. Right hand side expansion is called binomial expansion. So in this binomial expansion, some of the coefficients are there, binomial coefficients. So x plus a, x coefficient is 1, a coefficient is 1. Before that, we can write x plus a whole power 0 also. Anything power 0, what, students? 1. Okay, so first term is 1. In second one, x plus a whole power n means x coefficient is 1, a coefficient is 1. X plus a whole square, observe that right hand side term. X square coefficient is 1, xa coefficient is 2, a square coefficient is 1. X plus a whole cube, observe that x cube coefficient is 1, x square a coefficient is 3, xa square coefficient is 3, a cube coefficient is 1. These are called binomial coefficients. How we are calculating binomial coefficient means by using Pascal triangle. I think already you know very well Pascal triangle. See here how to write the Pascal triangle. First write the 1 and always edges write the 1. 1, here 1, here 1. In between these two, sum of these two terms, 1 plus 2, 1 plus 1, that is 2. Now how to write that next one? 1, 1 plus 2, 3, 2 plus 1, 3, and last should be 1. So in binomial expansion, first and last term having that binomial coefficient is 1. See here, already I am written Pascal triangle here. Already I am written Pascal triangle. Just observe that. Just observe that. And this x plus a whole power 0 means this. X plus a whole power 0 means we are getting coefficient is 1. X plus a whole power 1, 1, 1. Those are the coefficient. X square plus 2xa plus a square. What are the binomial coefficients here? 1, 2, 1. Here is a 1, 2, and here also 1. Now see the third one, 1, 3, 3, here 1. See this? 1, 3, 3, 1. Now students tell me how to write x plus a whole power 4 expansion. Already we know that the first term is going to decrease x power 4. Second term is going to increase. Here will come a power 0. But observe the binomial coefficient. First one 1 into x power 4 plus 4 into x cube into a plus what is the next binomial coefficient? 6 now. 6 into x cube is going to decreasing, that is x square. A is there, a is going to increase, a square plus after 6 what is there students? 4 right here. 4 into x square is going to decrease now, so we get x. A square is going to increase, a cube. And the last one what is there? 1. That means a power 4. This is x plus a whole power expansion, x power 4 plus 4x cube a plus 6x square a square plus 4x a cube plus a power 4. So by using this Pascal triangle, we can expand x plus a whole power 5 also. This expansion, try yourself students. Okay students, are you understood? By using these binomial coefficient, expand that x plus a whole power 5. The first term degree is going to decreasing. The second term degree is going to increasing. And one more thing, observe that here the power is 1. How many number of terms are there? 2. The power is 2. How many number of terms are there here? 3. The power is 3. How many number of terms are there? 4. But suppose x plus a whole power n expansion. How many number of terms are there? N plus 1 terms, because that started with 0. Degree 0 now. X cube, x square, x power 1, x power 0. A power 0, a power 1, a square, a cube. Like that. The power whatever is there, add 1, you will get number of terms in binomial expansion only. Okay students, if n is a positive integer, then x plus a whole power n expansion. This is the expansion. nc0 x power n plus nc1 x power n minus 1 into a plus nc2 x power n minus 2 into a square plus and so on ncr into x power n minus r into a power r and so on. The last term we can write ncn into a power n. If n is a positive integer, then how to write x plus a whole power expansion means this is the formula. Now this is we can write in short form sigma ncr into x power n minus r into a power r. So what is the r students? r is equal to 0 to n. This is the limit. Now what is x minus a whole power n expansion? X minus a whole power x expansion, same above expansion like that only, but we get alternative sign. First positive, nc0 x power n minus nc1 x power n minus 1 into a plus nc2 x power n minus 2 into a square minus and so on, plus here this term is positive or negative, we don't know, that's why I'm writing minus 1 whole power r ncr into x power n minus r into a power r plus and so on. The last term should be, if we don't know positive or negative, that's a minus 1 whole power n into ncn a power n. If n is even means it is going to positive. If n is odd means it's going to negative. Okay, students. Now this is, we can write in short form, that is equal to sigma r is equal to 0 to n minus 1 whole power n minus 1 whole power r, because limit is r is equal to 0 to n, or not, minus 1 whole power r ncr into x power n minus r into a power r. Here nc0, nc1, nc2, nc3 and so on, ncr and so on, ncn. These are called binomial coefficients. How we are calculating binomial coefficient means by using Pascal triangle. Now see here, I'm written two expansions. Take any one of the expansion, the number of terms in that expansion. So here starts with nc0, end with ncn. Starts with nc1 to ncn mean there are n terms and this term is extra. Totally how many terms are there? There are n plus 1 terms in binomial expansion only. Okay, trinomial, quadrinomial, it is going to change. Okay, students, the number of terms in the expansion of x plus a whole power n is n plus 1. N plus 1. Now, next point. See here, the sum of the powers of x and a in any term in the expansion of x plus a whole power n is n only. So any term you can take. For suppose I am taking here the sum of powers. Here observe the powers n minus 2 plus 2. Add these two, minus 2 plus 2 cancel. What we are getting, students? N or not? The sum of powers of x and a in any term in the expansion of x plus a whole power n is n. Okay, students. Now I'm going to discuss one more point, that is the general term in the expansion of x plus a whole power n is tr plus 1 is equal to ncr into x power n minus r into a power r. Okay, so general term, that means r plus 1th term, tr plus 1. tr plus 1 is equal to ncr into x power n minus r into a power r. This is called general term in the expansion of x plus a whole power n. For suppose x minus a whole power n expansion, what is the general term? This is a general term. tr plus 1 is equal to minus 1 whole power r into ncr into x power n minus r into a power r. That is general term in the expansion of x minus a whole power n. Students, observe here. Fourth point. Fourth point, 1 plus x whole power n expansion. This point, 1 plus x whole power n expansion, that is equal to r is equal to 0 to n ncr into x power r. Here, the first term is 1, second term is x. 1 power anything, 1 only now. So now I am going to expand this nc0 plus nc1 into x plus nc2 into x square. Second term is going to power is increasing. Yes or no? And so on and so on. ncr into x power r plus and so on ncn into x power n. This is 1 plus x whole power n, 1 plus x whole power n expansion. Similarly, tell me what is 1 minus x whole power n expansion? That is, we can write in short form sigma r is equal to 0 to n minus 1 whole power r into ncr into x power r. This is short form. Now expand that nc0 minus nc1 into x plus nc2 into x square, nc2 into x square minus nc3 into x cube plus and so on and so on. Here this term is positive or negative, we don't know. Minus 1 whole power r ncr into x power r plus and so on. The last term also positive or negative, we don't know. Write that minus 1 whole power n into ncn into x power n. This is 1 minus x whole power n expansion. In 1 plus x whole power n expansion, ncr into x power r, this is called general term in that expansion, 1 plus x whole power n. But 1 minus x whole power n expansion, here see that minus 1 whole power r into ncr into x power r. This is called general term in the expansion of 1 minus whole power n. So tr plus 1 is equal to ncr into x power r. This is general term in 1 plus x whole power n in this expansion. Yes or no, students? This is general term in 1 plus x whole power n expansion. And observe the sixth point. This is already we are discussed. nc0, nc1, nc2 and so on, ncn are binomial coefficients. Binomial coefficients in that original expansion x plus a whole power n. Okay, so those are binomial coefficients. Now I am going to discuss another point. See the seventh point, what they are given. The binomial coefficients which are equidistant from the beginning and the from ending are equal. So already you know that Pascal triangle. Once again I am writing 1, 1, 1, 1, 2, 1, 1, 1 plus 2, 3, 2 plus 1, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Here observe that the first binomial coefficient, last binomial coefficient, both are equal. Starting to second, ending to second, these two are equal. And starting to third, ending to third, these are equal. Sometimes one of the term is going to remaining. Okay, so if n is even, if n is odd, now here the binomial coefficients which are equidistant from the beginning and from the ending. So this is also very, very important. So that means here NC0, NC0, NCN, first and last. NC1, this is the first one. NCN minus 1, this is the last one. NC2, second one, starting to third one, ending to third one, NCN minus 2. These are equal. By using these terms, we are decided this is the formula. NCR is equal to NC N minus R. Remember it. NCR is equal to NC N minus R. Right. Now we are going to discuss that eighth point. See the eighth point. The expansion of x plus a whole power n and a plus x whole power n are equal, but their respective terms are not equal. X plus a whole power n, a plus x whole power n, both are looking at equal only because in between addition is there now. 2 plus 1, 1 plus 2, that value should be same. So whenever in binomial theorem, whenever we are expanding, the respective terms are not equal. Okay. In x plus a whole power n expansion, what is the first term? NC0 into x power n. But a plus x whole power n expansion means what is the first term? NC0 a power n. These two are not equal. So the respective terms are not equal. Right. In x plus a whole power n expansion, x minus a whole power n expansion already we have discussed. And if you are add both the expansions, what we get, sum of the terms is going to cancel. So we get the remaining terms. Or you can write here, x plus a whole power n expansion means NC0 x power n plus NC1 x power n minus 1 into a plus NC2 into x power n minus 2 into a square plus and so on. This is x plus a whole power n expansion. If x minus a whole power n expansion means NC0 x power n minus NC1 into x power n minus 1 into a plus NC2 into x power n minus 2 a square length. So these two is going to cancel. So NC0 terms, NC2, NC4, those terms are be remaining. Okay. Now I am going to write x plus a whole power n expansion plus x minus a whole power n expansion. So this is the expansion 2 into NC0 x power n plus NC2 x power n minus 2 into a square plus NC4 x power n minus 4 into a power 4 plus and so on. This is x plus a plus x minus a whole power expansion. Now similarly write that x plus a whole power n minus x minus a whole power n. Students, how to write that expansion? 2 into NC1 x power n minus 1 into a plus NC3 x power n minus 3 into a cube plus NC5 x power n minus 5 into a power 5 and so on. This is x plus a whole power n minus x minus a whole power n expansion. Okay. How many number of terms are there in that expansion? How do we know that? If n is even, there are n plus 2 by 2 terms. If n is odd, there are n plus 1 by 2 terms in that expansion. Okay. Now see that the number of terms in the expansion of x plus a whole power n minus x minus a whole power n is n by 2 if n is even. n plus 1 by 2 if n is odd. If n is odd, either x plus a whole power n plus x minus a whole power n, x plus a whole power n minus x minus a whole power n, the number of terms should be n plus